So we're going to be using this. This is an ADI data acquisition system. There are several different types of these sort of systems. And essentially what they do is they collect data digitally and then display that on a computer screen. And I'll show you the computer screen in a second. This should come set up when you come in, right? It'll be on, the computer will be on, but just to give you an idea of a few things that are here, we have various inputs, right? So these are inputs you can use that are you can put a wide variety of things that might measure amplitude of an action potential. They might measure force transduction. You can get various devices that measure force maybe and convert that into electrical signal. These are meant to be used with non-humans, right? The one on this side is also can be used to measure things, but it's shielded in particular ways so that it's safe for humans to use. We also have the ability to deliver light shocks, right? So you see we have an output here, and so we could deliver electrical shock, or we could have something where we signal that we need to start recording. So another thing this thing can do is I can say if I press a button and send a signal in, then I want to start recording, right? Or if a particular event happens, then I want to start recording. So it has quite a bit of flexibility, and this is actually quite a powerful instrument if you really know how to use it. We're going to be using it in a fairly simple way. Okay, so once you get started, at some point during your experiments, you're going to come to a screen that looks something like this. And this is a physical representation of the data you've collected. So just to give you an orientation, this is an EKG, and you can see some of the various waves we'll be talking about, the ST wave and so forth. On this axis we have the time, right? And on this axis we have the amplitude measured in millivolts of this particular signal. Now, you may notice that there's a little bit of a problem here, and that is that I'm seeing, for example, about 4 heartbeats, and this is because this represents, about 2 or 3 seconds of screen time. Now that may be fine for some things, but maybe we want to get a little bit of a better idea of how much time is between, for example, this point and this point. And it's kind of hard to measure because the boxes are representing a lot of time. So I can change the scale to enable me to measure that a little bit more easily. All right? So I can expand the scale. And what that does is it makes each one of these boxes worth less in time, right? So it's easier for me to see particular data points. Sometimes in class we'll be doing things where we actually collect data points a little bit more, but you can see that I've spread this out and I can see how long very small events are. On the other hand, I may want to look at something like how many times is the heartbeat per minute, and you can see that would be kind of hard to see at this particular scale. So I can also scrunch things up some. Oops, I'm going the wrong way. Like so. All right, and here I can see that I have, in fact, about 10 seconds worth of data, right? And I can see that in this particular time, looks like the heart beat about 8 or 9 times. So that's going to help me look at things that are longer term. Now, the other thing we can change is the amplitude. So I'm going to take this back to sort of where we started as far as the way it looks, right? And you can see that we can see different waves, right? But what we also want to do is we want to maybe measure the amplitude, how big these are. And in this particular case, these are measured in millivolts. But it's kind of hard to measure this because the scale is so big. So I can also change the scale of this. So let's say we have something that's very small. I want to look at it in more detail. I want to be able to measure it more carefully. I can make each one of these things bigger. And what I'm doing is I'm just expanding the scale, right? So previously things ran from 0 to maybe 2 millivolts on the screen. Here they're only going from 0 to 0.5 millivolts on the screen. So I can see a lot more detail. On the other hand, I may come to a case in which the signal is really large and it's off the screen. So let's imagine that I have the screen set up like this, but then I measure something that's 2 millivolts. Well, it's going to be up at the top of the screen. I can't even see where the top of it is. So in that particular case, I want to take negative down and scrunch it. So again, all I'm really doing is changing the scale. It would be like if you were asked to draw a graph in class, and you could set your scales, making them very scrunched up or very spread out. So that's essentially what they had, some of the basic things for you, how you operate this system. And I'm going to go over a little bit how this particular setup is going to go. So welcome to the setup. So you should have read through the introduction, which will talk a little bit about the origins of EKGs. And now we're going to be ready to start attaching our equipment. Now some of this will already be attached when you come in, or another group will have done it, but I'm going to show you just a little bit about what we're talking about. So this is going to go into the machine. This carries whatever information you're processing into the AD instrument, and where it will be converted to digital data for recording. This, right, is a little end that's going to allow you to hook up various things to record pieces of data, right? And so you can see it has 5 little slots in it, okay? The bottom slot is the ground, so that's going to be an electrical reference for everything you measure. And then you have 2 slots that are dedicated to channel 1, 2 slots that are dedicated to channel 2. So we're only going to use the 2 slots dedicated to channel 1. And so we have a positive and a negative for each of those slots. Now you'll notice that they are color-coded, so in this particular case it's a little bit odd for you guys who have hooked up stereos. This is not necessarily the standard thing, but negative here is white, positive is black, and then the earth ground, which again is your reference, is green. So these are what the wires look like. This is the ground, for example. It has an end that fits into the slot, and then it has another end which can fit into a little pad, and we'll come to that in a second. So what I'm going to do is I'm going to hook these up. Color is very important. We want to make sure that you have everything in the right place. So for example, the white needs to go in the white. And there's only one way they can fit. Just I got that wrong. The black needs to go into the black. And the green needs to go into the green. So it should look something like this. Now you'll also notice that these wires are going to go to particular places. So for example, the black, which is positive in this case, is going to go to, let me make sure that's right, the left arm, and the black, the other one's going to go to the right arm. The green is going to go around your ankle. Okay. The color is not that important. It's just that the color coding helps us figure out where things are going to go. If you switch the arm electrodes, for example, you'd essentially record the same data, but everything would be opposite everybody else. So that's not so great. So for comparison's sake, we want to make sure we keep everything the same. Now for each one of these, you'll notice that the end has a little kind of button clip into it. And so we can clip stuff into this. When we're talking about the ground, what we're going to clip in is a little strap, right? And so you're going to be able to take this, we'll see, we're going to, a second here, we'll put a little gel, and you'll be able to clip that on, and you're going to wrap this like so, and put that around your ankle. So if you happen to have large calves, right, if you got a muscular calf, that might be a problem, so you got to pick somebody scrawny in your group. The ones that are going to attach to the right and left arm are going to go into a little electrode pad. So I'm going to pull out an electrode pad. This is an electrode pad. It has a snap which will fit into one of these, so I'm going to put the snap in. It does have some adhesive, so it will stick to your skin. And then the center here, it has a little gel, right? And so basically that's a conductive material which will measure electrical charges that are conducted in your skin that are actually coming from the heart. You can measure those. So that's basically helping us conduct things. Sometimes that's not enough, right? Sometimes that's not conductive enough. In order to get around that, we have a gel, which I'm going to grab here. And you can take a little bit of this gel. It's clear. Basically, it has electrolytes in it. I can put a little bit on my finger. Some of it's, sometimes this is a little bit consistency of Vaseline. Sometimes it looks a little bit more like a hair gel. But whichever type of gel you use, you just put a little bit of that on the pad, and that should help in your measurements. So, you know, when you get hooked up, you'll have one on each wrist. You'll have the ground down around your ankle. So, just a word of caution. I would take a little bit of this gel and try it on maybe a little bit of your skin. We have had people have, one person out of about 200 people who's done this has had a slight allergic reaction to it, which actually started right away. So that should be rare, but just make sure that whoever's doing it, that if they start itching, that's what's going on. So that's the setup. You basically follow the screen. We'll be around to help you, and then we're going to come into the next section where we're going to record some data. Okay, so here we are on to step 2. This is going to be a little tricky because it's really hard to run this and record from yourself. As the instructions explain, you want to really make sure that the person who's getting recorded from is being still. All right, so it's going to be a little hard for me to do. But I've got everything hooked up. Everything's color-coded. I've got my ground on. And what I'm going to do is I'm going to hit start here, and hopefully we'll get something right? And so you can see that you can really nice see the RST wave, which is that big spike. And you can see the T, which comes after it. And so we'll talk about this in class a little bit eventually. And you can see my heart rate is elevated a little bit. Now, there are a few things you can do. We mentioned the fact that you can change the scale. All right, and the electrode just came off. By playing around with this, right? So this makes things, scrunches it up a little bit. You can see I'm seeing more of the record at a time. I can change the time like that to decompress it a little bit. Right, they were back to normal. I can go up and down in size. Right, so we're basically making it easier or harder to measure the amplitude of this. This little guy right here, which is kind of the third button over, is called auto scale, right? And it gives you supposedly what might be the best thing for you. And it's not so great, so I'm going to change that a little bit. Okay. Now, a few things here as you're doing it. If you have problems where you're not seeing anything, I would check your connections. You also want to make sure you keep your movement down, because anytime you move, you're creating other electrical patterns that would be measured. You want to make sure if you're not seeing anything, it might be that you don't have enough gel. So if you're not seeing anything, have us come over. Now, it's recording all of this. Right? You might can't see it from here, but it's now says we're about minute 30. So it's recording this entire bit of data. So I can stop this at some point, and all that data is saved. So I'm going to take my electrodes off, and hopefully this will allow things to be a little bit easier to see. So it will tell you on the next step what to do. So I'm going to go to the next screen, and you just go to next. And if I scroll through this, if I take this bar and just move it through, I can see all the different stuff that I recorded. Right? I can still change my scales, like so, if I need to, because this is recorded data, and this is just showing you how it's represented differently. This is probably a good little portion here to look at, because it doesn't look like it was too messed up yet. The next part of this tells you to do some measurements, and what I've done is I've scaled one of these particular EKG events to a point where it's pretty easy to see. This would be 1 heartbeat, so here the heart would be resting. Actually, up here would be resting. This is the P wave, which we'll talk about in class. It's actually caused by the atria contracting. Then we have the QRS, right, which is caused by the ventricle contracting. And then we have this T wave, which is caused by the ventricle relaxing, right? So we want to be able to see what the amplitude of each of these are, and we can also measure time between and things like that. So what I'm going to do, they talk about measuring the amplitude. Now you'll notice there's a lot of noise here, and hopefully that will be a little better in your recording. But you'll also notice that we're not actually at 0. Right? Here would be 0, we're above that. So we want to measure things relative to some baseline. So I'm going to say that this is approximately the baseline. And I'm going to want to measure everything from that. Now, there's a little nifty way you can do that, and that is to take this little thing that looks like an M, which stands for marker, and this allows you to set a baseline. So it's kind of where you thing would home. Right? So I'm going to put it right about here, which looks to be kind of, things are going up and down. This looks to be about the right place for it to go. I put it there. And then this little bar, as I move it, will tell me how far away I am from that baseline. Right? So here I'm about at the baseline. The top of this is 0.113 millivolts higher than the baseline. This big guy here at the very top is 0.4 millivolts up higher than the baseline. And then our T is about 0.2 higher than the baseline. All right, so I can get the amplitude of each of these things. It also tells me how far I am away in time. So this marker here is just, I've set it sort of to help me get the baseline for amplitude. I can also move it, right, and put it right here at the beginning of, for example, the P wave, and then I can ask, well, how far apart is the P wave from the top of the QRS wave? So I have this essentially going to set it to 0, and you'll see down here it will tell me that this guy here is not only 0.366 millivolts higher than this point, but it occurs 0.2 millivolts after this time point. So I can set this any place and measure relative to that point. So when I get done with it, I just put it back in this little home here. So I think that should get you fairly far. We'll have something where you're going to fill out, some amplitudes for these different points, how far some of the points are between, and what you're going to do is you're going to try to find a representative heartbeat and then measure them. Now, you can also measure you can also figure out heart rate with this. the way I would do that is I would set a marker at one point. Let's use this guy, okay, like so. And I'm going to ask how far it is to the next point that looks exactly like it. So if I do that, I find the next point looks like it is about 1.06 seconds away, right? And the next one, is about 2.29. The next one is about 3.45. So I can measure 3 or 4 beats out, divide by 3 or 4, depending on how many measure, and figure out what the resting heart rate is. So mine looks like it's around 58 or something like that. Not too bad for an older gentleman. All right, so hopefully that will be a little bit of a help, and we'll be doing this in lab, and hopefully it'll all work out.